Okay, I'm going to take the quizzes. Make sure you circled everything. Did you circle something for everything? Double check it, yes. You want it? So now we're going to move forward into the shortcut of finding the derivative. Yes. So up until this point, we've been doing it very much the long way, or the long two ways, I should say. The traditional way of finding the derivative and then the alternative way. And they have their purpose. They give you conceptual understanding of what it is that we're actually doing and the logic behind finding the slope of a tangent line as 2 points on a curve get closer and closer together. But they're definitely the long way. And the power rule is the most basic shortcut so far, and then the shortcuts are just going, the certain formulas and stuff that are going to create shortcuts are just going to continue to build on top of each other. So if you jump down to the bottom of your note sheet, this right here is the power rule. So d over dx, meaning the derivative with respect to x, we're taking the derivative of some base x to an nth power, okay? And what the formula says is that to take the derivative, you're going to take that exponent out in front, and that's where this n comes from, out in front, and then the exponent is reduced by 1. So if it used to be n, now the new exponent is n minus 1. So if I pull out any of the notes over the past few weeks, like this one, we had to find the derivative of that. Now, this is a polynomial. We're going to do it piece by piece. So the derivative of 5 is just 0, and that's that first rule right there. The derivative of any constant, by the way, this is supposed to have a d in front of it. That hole punch that was on the original copy kind of cut that out. But the derivative of any constant is 0. So when you take a polynomial, the derivative of each piece, the derivative of 5 is 0. The derivative of negative x squared, that 2 would be brought out in front of the x, so it would be negative 2x, and then the exponent of 2 gets reduced by 1, so it's now down to 1. So the derivative of this, after a whole bunch of work, we found was just negative 2x. And that's what the power rule is going to tell us. And I could do this for pretty much any example. There's a few examples where the power rule is going to be tricky. But so starting with just basic monomials. The derivative for this, f prime of x, we take the 3 out in front, and we reduce the exponent by a degree of 1. So the derivative is 3x squared. The f of x plus h process would take us about 3 minutes, and that takes you about 3 seconds, okay? It can get tricky, though, so this is the cubed root of x, which first and foremost you should rewrite into exponential form. So now to get the derivative, I follow my power rule on the exponential rewritten version. I bring that 1/3 out in front, and then I have to reduce 1/3 by 1. What's 1/3 minus 1? Negative 2/3. So that's my new exponent. And then, of course, I need to clean this up, okay, because negative exponents are not appropriate. So this negative exponent section would move to the denominator, so it would be 1 over 3x to the 2/3. And then you may see that x to the 2/3 is also rewritten back into a radical form. So it would be 1 over 3 times the cubed root of x squared. And that's your derivative. That might be a derivative that, with the f of x plus h way of doing it, would probably give us some trouble. I'd have to play with it, but the power rule is pretty foolproof. Again, as far as rewriting, 1 over x squared should be rewritten as x to the negative second. And on another note, this one is written as y equals, as opposed to the previous two were written as g of x or f of x. So if it's y equals as your function, then to notate the derivative, we're going to do y prime. And Elise, what would this initially be if we were following the power rule? Perfect. Bring the negative 2 out in front, drop that exponent by 1 degree, and then we'll clean this up. So this negative exponent piece needs to move to the denominator. So negative 2 over x cubed. And there's your derivative. Okay? Number 4, I would just probably, it is rewriting, I guess, technically, but it's almost like interpreting. I would just interpret that 4 over 5 as a coefficient of 4/5. Now, if I bring my 2 out in front, and there's already a 4/5 there, it's going to get multiplied. So f prime of t, I'm bringing my 2 out in front, 4/5 times 2 is going to be 8/5, and then it's just going to be t to the first power. So that's done. In 5, again, the rewriting in the beginning tends to is starting to become more important. I would rewrite this as y equals 1/2, and then this would have been x to the 2/3, but it's in the denominator, so I'm going to write it as x to the negative 2/3. So it's kind of in the numerator now. Now I'm going to follow my power rule. So y prime, I'm going to bring my negative 2/3 out in front. Negative 2/3 times 1/2 is negative 2/6, which we'll clean up in a minute. And then what's negative 2/3 minus 1? Negative 2/3 minus, yes, negative 5/3. So you got to be somewhat quick about that process. You don't want that to be what catches you up here with derivatives. Negative 2/3 minus 1 is the same as negative 2/3 minus 3/3, negative 5/3. So then this is going to bump back down to the denominator, and negative 2/6 I'm going to reduce to negative 1/3, and then x to the 5/3. If it's open response, I'm fine with exponential form. If you want to change it into radical form, that's fine. But we get the idea of the power rule. Okay? On 5, when I initially rewrite this, I would probably get rid of those parentheses first. What's 2 to the 3rd power? 8, and then x to the 3rd power. So I now no longer have the parentheses, and now I'm going to bring that x to the 3rd out of the denominator. So this will be 5/8 x to the negative 3rd. And that's my easiest rewritten form. Sam, what's the power rule going to do for me here?
Special?
No, that's fine. Thank you so much.
You're welcome. Hello.
Perfect. Negative 3 comes out in front. Negative 15/8 x to the negative 4th, and then we're going to clean that up and bring that x to the negative 4th to the denominator. Perfect. All right. And then we have some now polynomials instead of monomials, which we just take term by term by term. So you'll see that rule down here. If you're trying to take the derivative of polynomials with 2 individual monomials, you just take the derivative of each one separately. So it's pretty straightforward. This one Dan, what's the derivative of x cubed?
3x.
Perfect. And Dylan, what's the derivative of the negative 4x part? Okay, well, what's technically the exponent right now? 1. So if you bring the 1 out in front and multiply it by negative 4, what do you get? Negative 4. And then what is 1 when you decrease it by 1?
Negative
0. 0. It'll technically be x to the 0, but what do you know about x to the 0?
1.
It's just 1, so that part doesn't even need to be written. And then the derivative of 5 is a constant, so the derivative of that is 0, so we don't do anything for that, and we're done. Good? Any questions on that? Okay. On this next one, g prime of x equals, what are you going to put for the first term, Lauren? Why 3? Why is there a 3 out in front? What's the current exponent? 4. So we should be bringing the 4 out in front. Does that make sense? Negative 4x to the third over 2, which we'll clean up, but we don't need to do everything all at once. Bryce L., the next one?
9x to the third.
Yep. And Bryce C., the last term? Minus 2. So the only thing we really need to clean up here is this negative 4 divided by 2 is negative 2x cubed plus 9x squared minus 2. Okay? I'm going to flip over to the back just to make sure we touch on the trig. Trig has a whole host of derivative rules, and we're going to start with the two most basic. The derivative of sine is cosine, and the derivative of cosine is negative sine, and you have to memorize those. So anytime you're using them, I mean, it's once you know them and you memorize them, it's pretty straightforward. If we want the derivative of 2 sine x, that would be, the derivative of sine is cosine, so that's just going to be 2 cosine x. It's not the power rule anymore. These are, trig has its own set of rules. Okay? Number 2, similar, just the sine is in there, so the derivative of sine, again, is cosine. Okay? And the last example, x plus cosine, it's a polynomial, so we're going to take the derivative of each piece of the polynomial separately. So y prime equals, what's the derivative of x, Aaron?
1.
Just 1. And the derivative of positive cosine is negative sine x. So we just would fill with the negative sine x. So 1 minus sine x is your derivative formula. Again, don't lose sight of what the derivative is for. So we will be able to find the slope of this curve at any given point just by plugging in the x value to the derivative formula. And it will give us the slope at 5, let's say, of this curve. Okay? So there's a section in the homework just with the instructions to write the original function, rewrite, differentiate, and simplify. That's what we've been doing on the front side. When we first rewrite, this is kind of part of the rewriting process where I would change this first to pi over 9x squared to get rid of the parentheses. And then I would move my x squared up top. So I'd have pi over 9, x to the negative second. So that's the rewriting that they're talking about. Just rewrite the original function so that it's conducive to the power rule. And then differentiate. So y prime is going to be taking this negative 2, multiplying it out in front. So negative 2 pi over 9, x to the negative third, and then simplify and clean that up, which would be just me bringing this x to the negative third back to the denominator. Negative 2 pi over 9x cubed. Okay? Any questions on that? Last examples just ask us to do similar things to what we've been doing. It's just now we have the shortcut to help us. So we want to find the slope of this function specifically at this point. So first we're going to find the derivative of this function. So f prime of t equals, Jess, what's the derivative of 3?
Just be 0.
0, yep, derivative of any constant 0, so we don't really need to acknowledge that. And then the second part, negative 3/5, or 3 over 5t. I actually should probably rewrite that first as negative 3 over 5, t to the negative first. And then I'm bringing this negative 1 out in front, which is going to make that a positive 3/5, t to the negative second, which is going to be 3 over 5t squared. So there's my derivative. Now let's evaluate it at the location 3/5. So f prime of 3/5 is 3 over 5 times 3/5 squared. We're just doing some arithmetic really here. Which is going to be 3 over 5 times 9/25. The 5 and the 25 will reduce to 1 over 5. So now it's 3 divided by 9/5. Keep, change, flip. We're going to get 15/9 as our slope at 3/5. Okay? And on the last one, we're going to want to simplify this out first. Rewrite this. So let's square the binomial. And distribute our 3. And once you do that, the derivative is fairly straightforward. Maggie, what's the derivative of 75? 0. Who haven't I heard from? Emily, what's the derivative of negative 30x? Good. And Jenna, the derivative of 3x squared? 6x, so plus 6x. So there's my derivative formula, evaluated at 0. So f prime of 0 equals negative 30 plus 6 times 0 equals negative 30 would be your answer. Good? Done.
In the last example, what did you simplify the final answer by? Reduce it?
It's just negative 30. What's to reduce?
No, the one.
Oh, this one. Oh, yes. Divide that by 3. Thank you. So 5/3 would be a simplified answer. Good. Okay? So your homework's there at the bottom.